Hello everyone. Today I'll be discussing the four properties of water. Before that, let's first do a quick review of hydrogen bonding. In order for a hydrogen bond to exist, there must be one hydrogen bond donor and one hydrogen bond acceptor. Hydrogen bond donors are usually nitrogen, oxygen, or fluorine. Hydrogen is never a hydrogen bond donor because in this case, hydrogen is being donated. As for acceptors, hydrogen bond acceptors are also usually nitrogen, oxygen, or fluorine. In both cases, carbon is never a hydrogen bond donor or a hydrogen bond acceptor. In a hydrogen bond, positive ions will attract negative ions. In this diagram, hydrogen bonding in water is being displayed. Here, oxygen acts as both the donor and the acceptor. This symbol I'm drawing here signifies that an ion has a partial charge. In water molecules, oxygen tends to have a partial negative charge, while hydrogen tends to have a partial positive charge. As a result, this hydrogen will be attracted to the oxygen of another water molecule, and the same goes for here. This dotted line I'm drawing represents the hydrogen bond that is occurring between these two water molecules. In this instance, this hydrogen is being donated by this oxygen, and this oxygen will be accepting this hydrogen, which forms the hydrogen bond between these two water molecules. One more thing before discussing the properties of water. Water has all these properties and is a good substance because it is polar. Its polarity allows it to have high levels of hydrogen bonding. Now for the properties. Water has four properties: cohesion and adhesion, moderation of temperature, insulation of bodies of water by floating ice, and being a versatile solvent. Note that it is not a universal solvent. The first property of water is cohesion and adhesion. Cohesion is when molecules of the same substance stick together. In this case, water molecules are able to stick to each other through hydrogen bonding. Adhesion is when molecules can stick to other molecules. For water molecules, they can also stick to other substances, including the inside of a stem. Both cohesion and adhesion allow water to be transported in plants. The water molecules stick together through cohesion, so the water is transported together. And since the water molecules are able to stick to the inside of the stem, the water is able to be transported up the plant like so. So basically, cohesion allows the water to stick together while being transported up the plant using adhesion. Cohesion also allows for surface tension. Surface tension is the measure of how hard it is to break the surface of water. In this picture, you can see that the water strider is able to stand on water because of the water surface tension. Since the water molecules are able to stick to each other due to cohesion, the water surface is able to support the water strider without breaking. Here, the main force of surface tension is due to cohesion. The next property of water is that it can moderate temperature and Earth's climate due to its high specific heat and high heat of vaporization. But before that, let's first discuss the difference between heat and temperature. Heat is the total amount of kinetic energy of the molecules of a substance, while temperature is the measure of the average kinetic energy of the molecules of a substance. The specific heat of a substance is the amount of heat that must be absorbed or lost for 1 gram of that substance to change its temperature by 1 degree Celsius. Due to its high specific heat, water is able to moderate air temperature by absorbing heat from the air when it is hotter than the temperature of the water and releasing the stored heat when the air's temperature is cooler than the water's. Water's high specific heat allows it to minimize temperature fluctuations of the water when it absorbs or releases heat. This allows the water temperature to remain within the limits that permits life. Heat is absorbed when hydrogen bonds break, since energy is needed to break these bonds. As a result, it cools the surrounding surface since energy is being absorbed. As you can see in this diagram, hydrogen bonds usually break when energy is being absorbed, and here it occurs during melting, evaporation, or boiling. here it's made explicit that the hydrogen bonds are breaking. On the other hand, hydrogen bonds form when heat is released from water. This results in the surrounding surface becoming warmer since heat is released. Energy or heat is usually released when water is freezing or condensing, as shown here. So as you can see in this diagram, hydrogen bonds are forming when the water is undergoing condensation or freezing. Water is also able to moderate temperature due to its high heat of vaporization. Heat of vaporization is the quantity of heat a liquid must absorb for 1 gram of it to be converted from a liquid to a gas. Due to water's high heat of vaporization, evaporative cooling can occur. Evaporative cooling is when energy is absorbed from the surrounding environment to break hydrogen bonds. The water evaporates and cools the surrounding surface. This is how sweating cools down the body, through evaporative cooling. The third property of water is that it can insulate bodies of water through floating ice. Let's first review the water anomaly. Typically, substances become more dense as the temperature decreases, but between the range of 0 degrees Celsius and 4 degrees Celsius, water becomes less dense as the temperature decreases. Since ice is less dense than water, liquid water, ice ends up floating at the surface of liquid water. Ice becomes less dense because the hydrogen bonds in ice are more ordered than in liquid water. In liquid water, the hydrogen bonds make the water molecules more congested and condensed in one area compared to the even spread of water molecules through hydrogen bonding in ice. So as shown in this diagram, the hydrogen bonds that occur in ice make the water molecules more structured and ordered and evenly spread throughout. But in liquid water, the hydrogen bonds make the water molecules more condensed in one area. As a result, water ends up becoming more dense than ice. Now coming back to how this helps to insulate bodies of water. Since ice is less dense than liquid water, it ends up floating to the top of the surface. As a result, bodies of water end up freezing from the top down, not from the bottom up like other liquids. This allows life to be able to exist under frozen surfaces of lakes and polar oceans since the water is still liquid under the icy surface and is maintained at life-permitting temperatures. Finally, the fourth property of water is that it is a versatile solvent. Note that it is not a universal solvent. The main reason why water is such a versatile solvent is due to its polarity. Its polarity allows it to form aqueous solutions. The different regions of a polar water molecule can interact with other ionic or polar compounds or solutes. Through this interaction, the water molecules are able to dissolve the solutes through the use of hydration shells. As you can see in this example, the water molecules are dissolving salt through the use of hydration shells. Once salt has been split into chloride ions and sodium ions, the water molecules interact with the ions according to their charge and dissolve the molecules. So over here, chloride is negatively charged. As a result, the hydrogens with the partial positive charge face the chloride ions and interact with it in order to dissolve them. Over here, the same situation is happening, but in reverse. Here, sodium is charged positively. As a result, the oxygens in the water molecules with the partial negative charge are facing the sodium ions and interacting with them in order to dissolve them. Through this process, water can also interact with other polar molecules like proteins and dissolve them as well. In the end, remember that water is good and the properties it has are only possible because water is polar, which allows for high levels of hydrogen bonding. These are the 4 properties of water. Thank you for listening and have a good day.